In the previous video, we learned about what the idea of a limit was, and we saw an example like limit as x goes to 3 of the function x squared is going to be 9, because if you look at the graph of this, and you go over here to where x is 3, then the y value that you're close to is going to be 9. However, there are some weird functions, generally piecewise functions, and this one right here actually has a special name. It's called the signum, or just the sine function. You don't really have to know the name, but just in case you're curious. And if you were to draw this function here, on the right side it's always positive 1, and on the left side it's always negative 1. And so what would happen if I tried to tell you to find the limit as x goes to 0 of f of x? You look at your graph around x is 0 and you say, what's my y value going to be close to? But the problem is, on one side your y value is at 1, and the other side the y value is negative 1. So you might try to say, well, let me give you both answers. It's plus or minus 1. Well, that would actually not be acceptable. Limits can only ever have a single answer. It cannot be two different numbers for a limit. Now it turns out that this limit then is actually going to be undefined. Or sometimes we will write the shorthand DNE for does not exist. There is no answer to this limit. Now there are going to be other functions that also have this same problem. Let me do a little side example over here. The limit as x goes to 0 of sine of 1 over x is also DNE. And the reason, if you were to try to draw this graph here, is it starts out kind of looking like a sine graph, but then it gets closer and closer and closer and closer and closer and closer, and then spreads back out over here. And so the idea is, if you try to look at 0 there, you have no idea what the y value is because it's just going back and forth so fast. There is no one y value to give it. So you can have different examples where the limit does not exist, but on this function over here, the signum function, even though the limit doesn't exist, there is still some structure there. You can give some information about what's happening, even if you can't get the full answer. Whereas this sine of 1 over x graph, you have no idea what's going on in the middle there. It's just a big mess. And so what they introduced was a new notation to give some information, even if you can't give all of the information. And these are going to be called one-sided limits. And there's both a right-handed limit and a left-handed limit. And what you're going to do then is you're going to write down the limit here. You're going to say x is going to 0 of your function. And the new thing you're going to do is you're going to put a little plus sign in the upper right-hand corner of 0. Now, that does not mean that I'm doing a positive 0. Because in fact 0 is not positive or negative. All I'm doing is when I put a 0 on the right upper corner means that I'm going at the right hand side of 0. And if I look at my graph here, on the right hand side of 0, my y value is always 1, and so this right-handed limit would have the value of 1. On the other hand, if I did a left-handed limit, which I put a little negative sign in the upper right-hand corner, and I look at my graph here and I say, okay, what's my y values on the left side of 0? And those are all at negative 1, and so my limit here would be negative 1. So again, I just want to kind of point out that when you have piecewise functions, sometimes you will have on the left side of the graph going to one value, and sometimes you'll have the right side going to a different value. and you want to try to make sense of them. And the way you do that is with one-sided limits. Let me give you another example of this. Let's say my function is g of x is x squared if x is less than 3, and it's equal to, say, 10 minus x if x is greater than or equal to 3. So what that means is the graph starts out with your nice little parabola, and then once you get to an x value of 3, you're going to stop being the parabola, and instead you're going to be this line with a -1 slope, and it's going to look something like that. Now if I were to ask you what is the two-sided limit of this function as you go to 3, this is going to be a DNE, because at 3 there is no single y value that's going to work. Right? There's going to be two different y values here, one on the left side, one on the right side. And we can find the one on the left side here by saying, well, anytime that I am the left of 3, the function that the formula that I have is the x squared formula, so that would give you a y value of 9 there. On the other hand, if I look at the right side, I am going to use instead the second formula here, and that second formula is 10 minus x, and that would be 10 minus 3 is going to be 7 there. And so you see those two different one-sided limits we have an answer for, but the two-sided limit does not exist. Now, really quickly here, notice that if I were to pick any other point whatsoever, any other point in my graph, and I were to look right and left of it, I'm going to get the same y value. So basically, everywhere else will have a two-sided limit, no problem. It's just this single point here where it switches from one formula to a different formula, and you have this weird break in the graph. That's where we're going to have different one-sided limits. And so again, when I'm asking you questions, I could ask you a two-sided limit, I could ask you a one-sided limit, I could ask you whatever I feel like, and you know how to handle each situation here.